Okay, so I just want to go over what we're going to be doing today. We're going to be exploring student-created art in DESMOS. We're going to review the standards for algebra, geometry, and algebra 2 and beyond if we get that far. We're going to look at equations and expressions and giving starters to students. And we're also going to be connecting it to Google Tools. And of course, we got our vision and our mission for our district, preparing our students for their future and for college and life beyond. I feel like the teaching standards that are covered by my presentation today will be engaging your students, understanding and organizing material, planning your instruction. You could use this as an assessment tool, and also developing as a professional today. I believe that we are going to be creating and innovative, and we're going to be collaborative today. As far as the math standards, I mean, these are just a few, but we're not limiting ourselves to these. We're going to be covering a lot of the math standards that are in second semester of any of the programs you're in. So I just want to introduce myself real quick. Hi. My name is Ann Kerr. I'm a Google certified trainer in our district. I'm a teacher on special assignment here at Knight High School. I've been in our district for nearly 20 years. And I taught math for several of those years. And as a special education teacher, I've basically been collaborating with gen ed folk for a good long time. So that's a little bit about me. And the reason why we're doing this training today is because when I did the training back in November, several of the people who were in the training with me wanted to spend some more time with DESMOS. We only got to spend maybe 45 minutes, 30 minutes, and they really wanted to spend a little bit more time learning how to use it as a tool for their students. All right, so on this page, I've got the link to DESMOS, but you can always open up a tab, desmos.com, and just open up a basic, kind of, well, you'll get the landing page. We'll look at that in just a moment. But anyways, this link right here will take you there. Okay, so this is DESMOS's landing page. So you can go in here. I've already logged in as myself, but you can log in as a teacher and you can present programs and stuff to students. Also down here at the bottom is like the art contest finalists, which is kind of cool. That just threw a few equations that you can draw images. So it's really, really neat. So I thought we could take a moment to kind of look at some of the drawings that are in here. And the nice thing is that so these are the drawings, the age ranges. So yeah, it's pretty intense for kids at that age. They haven't, super creative kids. So you can go into any of their drawings and you can see the equations that they used. So they've gone and labeled things, which is kind of nice. So if you undo that, you can get the finer details of that particular equation. So what DESMOS is going to do is going to draw that image that I just clicked on. It's kind of cute. So anyway, so you can, like, if you're like, I wonder, how do I make whatever part of this drawing, you can come in here and you can see the equation that they use. So the roses on the left, this is their equations here. So all of these made roses on the left. So it's a good long list to accomplish roses on the left. So if you were wanting to know how could you copy it, that's how you would go about copying it. It would take a while. So anyways, I just want to give you guys kind of a peek view there. So we did, the last time we were together, we practiced how to draw a face. We did a smiley face. And so if you want to go ahead and open up a DESMOS, go to the graphing calculator. There's a link directly to the calculator. And you can start by typing in the equations that are going to get you to a smiley face. So first off, we got to start with a circle. So we need a circle. So in order to accomplish a circle, we're going to go ahead and we're going to go x minus h, and then to the second power plus y minus k. That's also to the second power equals, I want a nice circle, so I'm going to go with 40. All right. So if you do it like this, then you can talk to your students about the implications of their numbers that they throw in here. So right now, H is 1 and K is 1. And so then you can show the students, you know, if I move this around, so H is going to get me something that's left and right, and K is going to get me something that's up and down. Okay. So I could go up to my equation. I could say, well, I want my circle centered. So I could maybe make this one a 0. And then I can move my left and right and find out where I want that one to live. And maybe I want to also have that one centered. So if I make those zeros, then I've centered it. I no longer need those equations, the little slider things, so I can go and move from there. And if you use your mouse and you use the scroll bar, you can back out and zoom in and out real easily. I'm going to just zoom there so I can see it. Okay, so now I've got my circle. So now I need some eyeballs. So I'm going to use that same equation to get some eyeballs going on. And I want my eyeballs to be maybe here. So this would be the center of my circle. So if I said that my x, I'm going to go over 2. And then my y, I want to go up 2. And then the size of that circle, I don't know what size I want for my circle. So I'll just throw a number in there. Ooh, that's way too big. And that's still too big. And that's about right for an eyeball. Okay. And so then I'm going to think about what kind of color I want my eyeball to be. So if you hold on that, I'm going to make the trace around my eyeball black. I'm also going to make the trace around my head black as well. There we go. More of a pencil sketch. So then if you know, like the reason why these are negative is because I did over 2, up 2. So those are positives. So I want to go backwards 2 and up 2. So what I could do is just copy that equation, paste that equation here. And so then the up part is going to be the same number, but I want to go left. So instead of -2, this is a +2, because a negative becomes positive. So I went -2, and it was already a subtraction. So negative. So you can talk about that with your students, that that's how you can get that part of it. Okay. So I've got my eyeballs. And now I might need a nose. All right, so I can work on my nose. I might make a circle nose. So I'll just copy that, make my nose. But I want my nose to be in the center. So there's 0, 0. It needs to be smaller than that for a nose. And red's good for a nose, so I'm going to leave that as my nose. Ah, there we go. Get that out of the way. All right, so I've got my nose. So now I got to figure out, so now I need like part of a circle. I don't need like all of a circle. So now I got to get fancy with my math. So I got to go all fancy out like. let's see here. I have to remember my equation for, oh yeah, we're gonna do it like that. Oh, I didn't do my pupils. I need pupils. So before I go doing math, I'm going to do pupils. All right, and I want it to be filled. So in order to fill it, I'm going to need to have, there we go. But I want to locate that a little bit differently. So maybe I'll make that smaller. Here we go. And you can talk to your students about like the inequalities. When you're making an inequality, you get to fill stuff in. So it's kind of fun. Alrighty, so this one, same guy, other side. But I want my blue eyes. I could have two different eye colors, but I think I'm gonna go with same eye colors. All right, so there we go. So I got my my pupils, but I think maybe for my nose, I think I want to fill in my nose. Ooh, yikes! My computer went blank on me. No, not power saving mode, you silly computer. There we go. Alrighty, so I want to fill in my nose, so I go back up here to my nose. And that's also got to be the less than or equal to, and there we go. I got my nose filled in. It's cold outside, so that's why I got a red nose. All right, so let's see. We've got our eyes, we got our pupils, we got a filled in nose, and now I need to work on my smiley. So I know that if I have an exponential, I can make that curved. I can have that curved line. This is where algebra 2 semester 2, or I mean algebra 1 semester 2 is where you're doing the quadratic equations. So you can start doing like a little quadratic equation. So you can bring that back into the mix. So I'm going to make a line. I want it to be kind of wide. So I'm going to try like a little decimal guy here. Okay, so I got that part of it. And so now I've located, so I want it to be down there at -4 for the smile, but I don't want, like, obviously this would look really weird to have my smile go off the page. So I need to restrict it. So I'm going to put that in the curvy brackets. So I want my smile to go from, I want it to be over here somewhere, over there. So yeah, so I'm going to try like some different numbers and just see what happens. There we go. So if I try that, I got my -6 and -2. So there's my -2. I'm not sure where the -6 part's at, but the -2 right there gives me my smile. And there we go. Have accomplished, smile. But this is a mouth, so a mouth should be red. So there we go, red mouth. All right, so then I also want to have a line going across to, you know, define my mouth. So I want that line to go across here at the -2. So I'm just going to draw a horizontal line at -2, but I don't want it to be forever. So I'm going to use my little curvy brackets, and I'm going to have it go from, I don't know, let's try some 3. There we go. That looks nice, but it's still part of the mouth, so hold on that. Turn that red. Okay, but then I want to have a tongue. I want to put a little tongue in here for the smiley face. So we're going to put tongue. So for the tongue, it's once again, it's another quadratic equation. So I'm going to go with my y equals, I'm going to go with opposite of what I just did. So when I did a smiley, I did a positive 0.18. I'm going to go upside down and do a negative 0.18. And then I need to bring that down. So maybe if I put it at 2.75, yeah, that looks about right. And then I need to restrict that. So, restrict it. So let's have it go from negative 3.37 to 3.37. There we go. So there is my cold weather smiley face. And that's a real simple one. If you just wanted to do like a quick review of a few little mathy things with your students, they could use some equations that they'd learned. Although I think circle is algebra 2 kind of concept. So if you're wanting them to practice their exponentials from their quadratics from algebra 1, you might have to hand them equation for circle. And so that way they could draw that bit. All right, so there's that, guys. So that was a review of what we did last time when I taught this back in November. And there's a video in there if you wanted to watch the video later and review how to do it. Also, there is a little guy here if you want to watch how to draw a person. So this one, he shows you how to use sine to do wavy lines for the hair, and also how to incorporate some motion. So there are art projects out there that kids have done where they use those sliders and a timer, and you can actually get some motion going. It's really cool. I highly recommend you dive into some kid art. All right, so because I want to get you guys to your own drawings here in a moment. So basically, my recommendation is that math makes some kids real nervous. A lot of kids nervous. So I would recommend giving them some starters, kind of like when you're working with English students and you're teaching them how to write, and you give them writing prompts, word banks, sentence starters. I recommend doing the same thing with math, giving them some, equation starters, some samples, some guided practice, some modeling, because otherwise they're going to kind of get lost a little bit. And, especially like I showed you how you can like look at somebody else's art and you can see how they accomplished it. But, that was that like picture of the lady with the flowers is very complex. But if you gave them something simple like a smiley face, to make a smiley face, it only took 11 lines. So versus many lines of equations. So, and also that was like the younger group, so they might have been doing multiple equations where they might have been able to combine some lines if they knew a more complex mathematical formula. So that's also something that's there, kind of like the difference between repeated addition and multiplication. The more they know, the less lines of code they need. Alrighty. So I just wanted to pull out some of the pacing guide. So if you're doing straight lines, that would have been in chapter 3, and for general ed, it would have been taught in September. These are all general ed pacing guide. And if you guys are anyone from the SDC Academic, I can look up where what time of the year you're teaching those. But anyways, graphing and exponentials, chapter 6 to 8, is just typically taught February to March. If you're doing geometry and you're looking at the equation of circles, that's chapter 10, March to April. If you're looking at polynomial functions, algebra 2 is chapter 4. It's typically taught January to February. If you're looking at rational exponents, that's algebra 2, chapter 5, typically taught in February. And if you're looking at exponential and logs, that's algebra 2, chapter 6, typically taught March to April. So if you're looking at where would you be in what book you're looking at, I give you guys like a little brief. All right, so we took a peek at the art that's out there. And we looked at this one here, the lady with the flowers. They're very complex. Even this eyeball one, pretty complex, all the different equations that went in to accomplish the fancy eyeball. So what I did was I went in and I looked at like, how could you model this for students? How could you show them the different ways to draw your equation? So I showed you guys when I initially did my circle, how you can throw in the H and the K, and then you can tell Desmos to give you the sliders for those, and you can see how they are impacted. So like the H on there goes back and forth, your left to right, and the K is your up and down because it's in there with the Y. And so you can talk about that with the students, the difference between X and Y, and then how that will be impacted in your equation. All right, you could also talk about vertical versus horizontal, okay, because that definitely trips kids up, vertical versus horizontal. So you could simply put, X equals a -10, show them how that shows up on your line, and then how to restrict it with the curvy brackets. And the same thing with the horizontal line, going back and forth. And so if you did Y equals 2, you get your horizontal line at the 2, and you could also restrict that with curvy brackets. Then if you want to get real fancy, since it's Valentine's, there's your equation for drawing a heart. And then there's a little video if you guys want to watch how to draw a heart. And I also did my own little heart. So you can play with, so this is the top one is the equation for the heart. And this one here is the equation for a little wavy line, because I'm not a huge fan of Valentine's Day. So I was seeing what I could do to mess up the heart. But anyways, kids can play with that. They can have fun with it. And you can talk about, so if you put a slider, so the video could show you how you can put sliders in. But you can put sliders in on this one too, and you can see like some of the equation will make your heart bigger, taller, and shorter. And then also you can, if you use the equation that I have with the right there with the absolute value, if you take out your absolute value sign, you end up with half a heart. Kind of cool. So different things you can do with that. So, and then this equation here that I snapshotted is how to accomplish a wavy line. And this one like ended at -4 and ended at 4 on the other side. So that's how you can restrict a wavy line. So kind of like if you wanted to draw the person with the, Simpson-like hair, there you go. That's the equation right there. Another fun thing you can do is if you want to do geometric shapes and you want to just define your shapes. So those of you who are in geometry and you're like, what's an equation for some crazy shape? You don't necessarily have to know an equation for a triangle to make this thing draw you a triangle. You can simply tell it you want to make a polygon and give it the points. So let's see, I have Polygon Shapes. There we go. So there we go. So if you give it some points, so I give it 2, 2, -2, 2, and 0, -2. So those are my 3 points here. And then on the next line, I told it I want to draw a polygon. and that I want to use these points A, B, and C, and it will allow you to draw a polygon. And the fun thing is, because of the way I defined it, I can stretch my polygon all over this thing because of the way I defined it. So there I can have my polygon be all sorts of things. So this is kind of like those geo boards that you guys used to have with the rubber bands. So if you do this, if you set this up, if you put A equals a point, B equals a point, C equals a point, and then say, draw me a polygon of A, B, and C with commas in there, you just drag this thing around and you get to have all sorts of fun. You can also make a table. So you can put a table of numbers. And then if you say, I want a polygon of the column X1, and then there's a comma in here, you can barely see it, but there's a comma here. And then you want to column Y1, and then that's what this shape is here. That's how I got that shape up there. Is by saying, here's my table of numbers. Draw me a polygon of that thing. Different ways to different ends. All right, so I've given you guys a bit of an introduction to how to kind of navigate some fun shapes on Desmos. Do I have any questions at this point? Are you guys all like Desmos experts? All right, so I'm a big believer in playtime, that if you guys get an opportunity to play with stuff, it's going to stick more. That's a special ed teacher in me. So I want to give you guys an opportunity to take these few little things that I've thrown out there for you guys, the modeling that I've done for you, to kind of give you some like basics, because it's near Valentine's Day, I gave you hearts. Because there might be some geometry people out there, how to just simply draw a basic shapes. So what I want to do at this time is I want to give you the opportunity to go into, and I gave you guys a link. So I got 6 people. So instead of doing groups, we'll just do people individually. So I will share this link because you guys get to go in here and doodle. So the link is in the slides. So if you have the slides open, you can just click and take yourself there. But otherwise, I also put it in chat. So what I'm figuring you guys could do at this point in time is take on a challenge based on what it is that you guys teach. So are you an algebra teacher? Are you mainly going to be working with straight lines and curvy lines? Are you a geometry teacher? Are you going to work with some shapes? Are you an algebra 2 teacher and you kind of want to work with all of the above, because they should have some of these skills. Maybe they might not have the shapes necessarily, but they definitely should have the sign and the heart shape and the circles down, or eventually have those down. Or you just want to have like a generic introduction to math, can be artistic. However you want to use it. Hopefully I've given you guys like lots of different like access tools to make your own art. So what I was envisioning was you guys have the workspace here. So if everyone could take their own slide and claim it and put your name on it, so that way you know that it's your slide. So you can erase the part that says group whatever and put your name there. So I should have somebody in just about all the slides. So go ahead and erase the group number and put your name there. And then have at it, draw some different shapes. If you want to like Google a video or something, or go to Desmos, you can go there and look at people's artwork. Because that's the nice thing about the mine. Oh, by the way, you can save your stuff. You can save your stuff, and then that way you can go over here and you'd have like a whole library of different things you've drawn. So that's kind of fun. All right, but once you have your image that you like, I want you guys to go ahead and export that image. There's different ways to the same end. So I'm going to do export an image. There's another way to do this too, but I'm going to show you this one first. So you go to your slide that you have claimed. I'm going to go ahead and claim way down here at number 10. And I'm going to drag and drop. And there is my image I just drew. So there's my smiley face. But I'm hoping you guys will draw something slightly more interesting than a smiley face. But if you want to like add all your different images so there's smiley face. And if I want to have broken heart, because why not? It's fun. So what I'm doing is I'm downloading it. I opened it into file here, the little folder at the bottom. And then when I go over here to the tab for our work we're doing here, I just grab it. No, not that guy. Grab this guy and just drop it. And you can resize it to your purpose. Okay. That's one way to get an image in there.
Wait, how did you do the image again?
Okay, so I went to my drawing that I completed. And in the upper right hand next to, because I'm signed in as myself. So next to my name, I did share my graph. There's this little box with an arrow going out of it. And then I click export my image. And then you can like choose what size you want. You could have a different sizes of shape. I just left it where it was at medium square with a thin line. I didn't need it to be super thick. So a thin line was fine for me. So I went ahead and just accepted those standards and then hit download. And when it downloaded, it took it to my folder. So there's my folder there. And then I went to, I'm going to get this guy out of the way, but I went to our shared group activity and I have my folder. And you just left click, drag that thing over to your slide that you're working in, and then just let go. If I let go, it's going to have like two heart things, but you just let go. And then it like takes a second to think about it, and it drops your images right there. And you just place your image however you like on your page. And so what I found also, besides looking at how the kids did theirs, you can also go to Google and you can type in like, I want to have like a wavy line, and ask Google that. And you say for DESMOS. And there are people out there who've like written what the equation is for whatever it is you want to draw. That's how I got the heart. Is I went to Google and I'm like, how do you draw a heart? And so there was a couple different hearts that were out there in the world. This one actually is a more simplified version of a heart than the other one that I found. So you can just play with stuff. You can be like, say I have a 3. What happens if I make it a 7? So that's kind of too big. So maybe I make it a 2. All right. And then you've got the number here in front of y. And so then you can just play with that number and see what happens. So if I make that a 1, then you just get kind of, basic heart shape. But what happens if I make it a 2? So that makes it squishy. Okay. But maybe I want it to be more tall. So I make a fraction. Maybe not quite like that. Ooh, that's even worse. There we go. So the closer to a whole number, the more kind of traditional heart shape. So you can just play with that. Also, the creator of the video said you could take the absolute value off your heart and you end up with half a heart. So that's kind of fun. Just play with stuff. And then this one here is a sine wave. And so originally this wave was going this direction, but I wanted it to go the other way. So I just changed like one of the symbols. I think I changed like a positive to a negative or something, or negative to a positive. I don't know. I changed one of the things. This is the fun of it. You know, you get to play with it and find out what happens. And then I put some limitations on it. And you can shrink it with some limitations. You can also, like, you can zoom into stuff too. Move it around. So then the other way that you could do this one, besides doing export it, students have like a print button on their keyboards on those Chromebooks. They have a print button. If they click their little print button, it will grab an image of this page, and then it will swing out a little message to the side saying, do you want to like put this on a clipboard? And then they can click yes, put it on a clipboard, and then they can go over to their shared slides and click Control V to paste. That's what I used to do in class, is I had them do that, because this image right here doesn't have all those equations off to the side, and I wanted to know what the equations were that my students drew. I wanted, you know, because that was kind of the whole point, is I wanted to see that they were utilizing the math that we had played and practiced with. So I had them snag images that way by hitting the print button, and then a message comes off here on the right, and I had them click copy to clipboard, and then they were to paste that in. If you're on a traditional PC, you could go and open up the art program. So you could go and you get this little plus guy here. You could go and copy your area. And so here it is in the snip. So you can snip the image. And then you can click on the little copy guy here. So this one is I think it's the new one, the updated snip and sketch. And you can click this guy and you can paste that in. It's another way to the same end. So are there any shapes that you guys would like to try to do, or you want to just see what the kids had on theirs? Because that's always fun to look at. So I'm not drawing flowers anytime soon, because that was just way too many. Let's see if we can find like a really young one where maybe it's not quite as many images. Look at that one. That is amazing. And they did that with just math. That's mind-blowing what they can do. So when you open up the artwork that students did, you have to wait a moment because Desmos has to draw it. And there we go. So in order to accomplish this really cool eye, they used some polygons. And so I showed you guys how to do, I showed you guys some polygons. So you can, like I said, you can define some space. Like I defined this like with a table. You can also define it with points. And just calling it a polygon will fill it in. So that's kind of cool. So that's what this kid did for some of their stuff. So if you're like, I wonder which one this one was, you can unclick it and it will disappear, and re-click it. It's supposed to come back again. I'm not sure where that was in the grand scheme of things because I didn't see anything disappear. I'm gonna click. Let's leave that. Let's see which ones they are.
It's one of the eyelashes.
That's what it was. It was the eyelashes and the eyeball. Because you can unclick the whole mess. So that was their polygons. That's pretty impressive.
Yeah, that is mind blowing.
Mm-hmm.
I've seen a lot of these like Desmos pictures before, but this is probably about the most complicated one I've ever seen.
I'm not seeing where linear functions adds to the image. Here's quadratic functions. I would have thought the eyebrows would have been, or I mean, yeah. Oh, I see. There's something underneath. So one little equation. So that's kind of cute how they've labeled it. Like I said, this could be like an assessment. It's fun, and they're also utilizing all the things you've taught them, as opposed to like, you know, a boring test. Could have draw a picture. So this one, they proved that they knew how to do a polygon, that they knew a linear function, that they knew quadratic functions, that they knew a cubic function, that they knew an exponential, that they had a square root. So they were able to incorporate these different little features to make their eye. That is so cool. I'm going to take out the polygons. All right, so let's see what we got. So if I did linear. Oh, wow. So just one little snap right here, the tear duct. That's cool. Okay, so then they used the one line down here as their quadratic. Cool. I don't see that one. So they've got an exponential function. This must be underneath something. Oh, that's cute. Just this little wisp right here was their rational function. Oh, well, the other function is the pupil. Huh, cool. But most of their thing was polygons. But that's pretty impressive. Oh, that is very pretty. And if there's any art that you like or you wanted to come back and look at their equations later, you can save it and it will save it in your account. It's kind of fun. All right, let's look at some more complex ones. Let's look at the 15 to 16-year-olds. Impressive. So they got Starry Night.
By the way, in case any of you guys were thinking that I'm totally awesome, I cheated. That's not my tessellation. I copied it. I was just playing around with it. But they have a template that you can use for that.
To make this?
Yeah.
Oh yeah. I think I've seen that one.
Because I was thinking for geometry, I like doing tessellation. So I was looking up tessellations, and they have like a template that you can use. You can play around and change the size of things and make like hexagons and triangles and all kinds of weird stuff.
Wow. And they're all like little lizards, and no matter which direction you're looking, that is cool.
I can't take credit though. I was just looking around.
Well, I was honest about my credit too. Like I taught SDC academic, algebra 1A, 1B. We did pre-algebra. I've been helping. I developed the curriculum for the integrated math 3. So it's got a little bit of algebra 2, a little bit of geometry, and a little bit of statistics. You know, I hang out with the math group, but I did not have as much math as they did. They go all the way up to calculus. The people I sat across from at the San Diego training, they had all these because they did calculus. They were able to make this thing do all sorts of amazing stuff. All right, so this is, there we go. That took a moment to download. Wow.
That's pretty cool.
That is impressive. Oh, and so they even had to do the frame as well. So this one, if you notice, they took out the lines. So normally, like DESMOS, you've got your grid. Well, no, here we go. You got your grid. So on this one, they took off the grid so that you could have a true appreciation for the art. So let's see what kind of labels they gave it. All right.
You got to wonder how many hours that this took a person to do. I mean,
well, it's got to be a while because I'm on line 2000s, now 3000s, 4000.
I'm thinking this would take like a month, man.
Yeah, this would have been like a big project they would have been working on for a while. Because this is 4,799 lines.
Oh my gosh.
Yeah.
If one of my students did that, boom, A+, you're done.
Mm-hmm.
You graduate. Congratulations, you graduate.
So what is it you teach?
What's that?
What level do you teach?
Oh, I'm teaching geometry, all geometry this year.
Oh, okay.
But I've taught everything up to AP calculus. So.
Very, very cool. So then you would be interested in those polygon shapes, how you can just like plug in a few points and then call it a polygon and boom, there you go, you got a shape.
Yeah, honestly, I used to use DESMOS a lot more, but lately I've kind of I've been using GeoGebra a lot more lately. I kind of like GeoGebra for geometry a lot more. Maybe just because that's what I've been using lately, but
Mm-hmm.
you know, kind of been my thing lately.
Does it work like those words from the
Yeah,
past?
you know, honestly, I think both GeoGebra and Desmos, they both pretty much copied off of each other because
Okay.
I've noticed that Desmos has now tried to emulate a lot of the GeoGebra features, and I noticed that GeoGebra has tried to copy a lot of the Desmos features, so they're kind of merging towards one another.
Ah, I see.
But they're slightly different. I think, you know, Desmos obviously has the market cornered because they've got their little calculator embedded in all of the different online books and AP tests and everything else nowadays. So
Yeah.
that's kind of the go-to one, but I still think GeoGebra is better for geometry.
Possibly. I haven't played with GeoGebra really, but I was really impressed with Polygon Shapes because I was like, how on earth are you going to, get some of these shapes these kids drew, with equations only? Not really.
Yeah,
You got
well,
to have a
GeoGebra, you
polygon.
don't necessarily need the equations. You just put the points and connect the lines. So it's kind of easier. It doesn't make them think as much. It's just, I mean, there is a way you can do it with equations too, but
Yeah. But it was kind of nice to just plug some points in and then boom, there you go. Because that's what I did here. And then, like, to be able to drag it around, kind of like, old days. Yeah.
what I like it for is I like it for like teaching like transformations, like reflections and dilations and rotations and all that. It just makes it so much easier than doing it the old-fashioned way because they can see it like right away, and it's also good for like teaching like congruence and similarity and all that.
What do you do? Like, do you tell it to make it a transformation or a reflection?
Yeah, you can exactly, you select like the object that you want to transform, and you can tell it, okay, I want to translate it, I want to reflect it, I want to rotate it. And so like if you reflect it, for example, you have to graph a line and you have to tell it, okay, I want to reflect about this line. And so you gotta first you select like your triangle, and then you gotta select the line, and then you reflect over the line, and it does it. It's pretty cool.
That sounds neat.
Yeah, actually, if you go on the in the drive that's shared with the district, I guess it's like the distance learning thing. I put my actually put my interactive notes for transformations using GeoGebra, and I put step-by-step directions in it. It's on the district shared drive, so if anybody wants to check that out, you're welcome to it. I had to put it there when we did the self-curriculum planning. I just shared it over there.
Oh, that's cool. Yeah, I shared
Yeah.
my stuff. I don't know if there's any sped folk in here today, but I shared our math pacing guide and all the resources. So it's all out there for our sped
Yeah,
group.
I appreciate that stuff, man. I look at all that stuff that everybody puts out there. I mean, you know, sharing is caring, like they say. We all steal things from each other.
Mm-hmm. Absolutely. This is a cute one. Very simple.
Yeah, I could see like, you know, where you could like tell the kids, okay, you're gonna like use functions to design your own emojis or something. That's what that kind of looks like to me.
Mm-hmm. Supposedly, This is, oh, there we go. Oh, they are making different faces. Oh, that's super cute. The eyes are just getting bigger. So they have like it's animated. I saw one where they animated it and it was like a choo-choo train.
That's pretty cool.
Mm-hmm.
It's really kind of incredible how far Desmos has come. I mean, it's grown by leaps and bounds since they first put it out there, and now they kind of like let different people contribute to it and add to it, and it's insane all the different things that it does now.
Mm-hmm.
It's just like you can't even keep. It's like regular Google. You can't keep up with all the things. It's just constantly growing at an exponential rate. It's just incredible.
Yeah. Well, look at this. They got the twinkly stars. They had a ghost. I think they could have improved on their pumpkin though.
Oh yeah, they could have done that way better. That looks more like a squished carrot than a pumpkin.
A little bit, yeah. Here's their equation for the pumpkin.
Maybe you can, a pumpkin would be like a whatchamacallit, like a cardioid or a, trying to think what you call it. You'd want to do it with like polar coordinates.
Well, I'll throw the pumpkin animation down here in chat. There we go. Maybe you can fix a pumpkin and pull that into your Desmos.
I don't know how to do polar coordinates on Desmos, but if I did, I could make that shape because I know in trigonometry how to make that. I don't even know if Desmos. I'm sure it does. Let me look that up and see if it'll let me do that.
So by the way, I'm giving you guys like time to kind of play with it and also for me to be here and support you and whatever equation help you need. But at the very least, I think like everybody should get like a smiley face and maybe a heart, or if you like a different shape, that'll be fine too. Or like Paul went and found tessellations. If you want to go above and beyond, you're welcome to. But if you could please put the results of your art on the slide with your name, so that way I could see that you guys did get it and that you're moseying along, and then feel free to do a gallery walk about what everybody else has been putting in here, because it's kind of fun to see what other people are doing and what kind of arts they're creating. But yeah, because art takes time. That's why we got a lot, that's why we got, time built in to kind of do some art. But while you guys are doing your art, I'm going to go ahead and I'm going to look at like the different things that are out there in the world, art-wise, and just going to see what their equations were. This really super cute, what they did here. Let's see if I can get lovely face. All right, so they used this equation for their heart. So it's kind of like the equation that I had, because you have your absolute value with your x term in there, but they've modified their x term to make their hearts a little bit different, also because they put their hearts off to the side. as opposed to where mine was like right here in the middle. So they needed their hearts to be over here, so they had to modify it. There we go. So the nice thing about Desmos is when you find something you like, you can go Control, Copy, and you can be like, I wonder what that looks like in my space.
Let's do this. So it's up at 30.
There we go. So you can use sliders to make things bigger, smaller, whatever. And then when you like what it is, you can replace the thing the slider was with the thing you like now. And I'll make those red. Oh. Come on. There. So then this guy down here, this equation must be the smiley part of it because it kind of looks a little on the heart side, but unfinished. Right, so there you get a frowny face. So instead of drawing each eyeball separately, they've done one single equation for the eyeball. So that's another thing is like the more the students know their equations, the less lines of code they need. So here they knew how to put two eyeballs on there. So there's our two eyeballs.
I figured out how to make the pumpkin shape, but I don't know how to. Now I just need to figure out how to make it shift up because that's what's tricky with polar coordinates because it's like.
Can you make a slider and use the slider to find out how that's changing it?
I could try.
So that's what I do when I'm not sure about some things. I create a slider. That's interesting. So the crying face, the tear drops down, but then sometimes the tear changes from the left eye to the right eye. Interesting. That's a cool animated one. I said, if you find something you like, you can always just save that. And it will be saved in your list. Things you liked. Alrighty. I'm going to save that.
I think what I would do
Mm-hmm.
if I wanted to use that polar for the pumpkin, because with the polar it has to be centered around, basically around the 0, because it's a different coordinate system.
Okay.
But you could take the other equations that you did in rectangular, they would be easy to shift down. So like, I think it would be easier to take everything else and shift it down and just leave the pumpkin right where it's at. Does that make sense? So like if everything else came down but the pumpkin stayed where it was at, then it would make sense. I don't know. Let me share my screen. I'll show you what I'm talking about.
Yeah, hold on. Let me go ahead and... All right, so when I did the heart with the original equation, it was this one here. This is the equation I used for heart, which kind of looks like the equation you were using for the pumpkin, but you changed a few numbers to make it more wide. Okay.
Well, you could make a heart with a polar coordinate too, but I see what you're saying. Yeah, you could actually probably adapt your heart and make it into a pumpkin, is what you're saying.
Mm-hmm. Because yours kind of looked heart-like, but just fatter. And so if that's the case, then the kid who did the heart eyes used this fun equation. And they made heart eyes with that. So they're kind of using elements of the equation number 1, but then of course they had to have it twice. So
no, I get you. That makes total sense to me.
So maybe I mean, you only need one pumpkin. So you got to figure out where is the duplicate in here. Remove the duplicate. Maybe it's the 2. I don't know.
Yeah, I know what you mean. Just copy it and then start playing around with the numbers in there and seeing what you could change to make it look. But actually, using what you said too, you could always stick sliders in different places in that formula too, and see. Like you were saying, I would let you change the values so you could see what would work best.
Yeah. So he really likes this 9 square root of 5 plus or minus the 9s. He really likes that part. Well, let's see. Let's make it H. I'll make all these parts H and just find out what happens if I'm... Yeah, because those are all 9s. So that's the location.
That's pretty cool too. You could almost do a whole activity just on like asking kids to figure out what parameter each one of those things controls and do like little experiments to figure it out.
Exactly. And that's the nice thing about this stuff is You can give them like I said, an equation starter. You can teach them some of the basic tools and then just let them have fun. And while they're having fun, they're actually learning a lot. Probably more than if we sat there and like talked about it forever. Because just, here, like I was like, well, what, these are all nines. What happens if I make a slider? What do those nines define? So now I know the 9 just defines where the hearts live.
It's kind of odd though. Like, why is it that the 9 would do that? That's kind of.
I know, right?
Interesting. Or I guess maybe it's not that it was a 9. It's just that where that particular, whatever that number was right there where H is, that controlled it. Yeah. But 9 was the location that he predicted before.
Yeah. So if I went back, replaced the 9s. So there we go. I got that back there. And maybe I could be like, well, these are all 9 square root 5s. What the heck is that? Oof. Okay, so interesting shapes.
What happens if you change the 2, make the 2 into a slider down on the denominator to make it like so that it's like.
Okay, so let's see what.
That's the location.
So that's the so this is the 9.
Oh, no, that's H you're playing with still.
Yeah, I'm playing with H. So the 9 to 9, so the regular 9, the positive or negative 9, made it go diagonal this direction, but then the 9 square root 5 makes it go this direction right here, and then the K, which was the 2, is back and forth. Oh, that is awesome. And then it beams and teleports. It disappeared at one point. Oh, that's trippy. So that's what that does. That's what the 2's doing. Wow. Interesting.
Yeah, I'm playing around with this. These are the kind of things that when you're bored in the summer and you start on it, and the next thing you know, you're like 10 hours later.
Yeah. Well, I mean, that's what the kid. I'm going to suppose what the kids were doing would they, create some sliders, find some stuff out, have these ghost heart eyeball things floating around. Oops. So that's what. So if you, wow, look at the shapes with a number. That's interesting. There we go. Just putting the 2 make them hearts. That is pretty trippy. And look at that. Just taking that that bit of the equation out of front of this guy here to the left, it flipped my heart upside down and made it wonky. That is trippy.
looks like you could almost turn that into like a hovering UFO or something.
Almost. Because like some of parts of these equations, like you take them off and you lose your shape altogether. See, like there, I lose my image totally. I wonder what happens if I take off the absolute value.
Then it's going to have some below the x-axis too, I think.
Interesting. I already did that one. That was just location. Let's see. So this -3. Of course, I want to get rid of that. So let's make this H. And make that H. Oh, look at that. So that's what the H does. It separates your hearts. There it is at 0. That's pretty cool. Well, that's interesting. So that's where you get the 2 hearts. Oh, did you see that? I took the number out of the middle. It flipped my heart.
Flipped it, huh?
Yeah.
That's weird.
Like if I do that,
Huh.
I get upside down heart.
That kind of looks like a nose when you turn it upside down. That would be a good shape to use for a nose for something.
It absolutely would be. So that's just straight up and down then.
Nice, Aaron.
Yeah.
That's cool. Oh, Matt did a good pumpkin.
Yeah, Matt made a nice pumpkin there.
Good job, Matt.
Thank you. I just took what you guys were doing and ran with it.
Did a slider?
I started with a slider to kind of figure out the right size, and then once I saw what it was, I just substituted like the A and the B with number that I put on the slider.
What kind of equation did you just go? Do you use polar on that as well?
I used whatever we started out with, that heart. I just started changing stuff in the heart.
Oh, okay.
Okay.
So they had like the heart. I was like, okay, it's kind of like the shape I want, and so I started messing with some exponents and coefficients.
Very nice. It
Nice.
came out very pumpkin like.
Yeah, did a good job on that. A+.
Yes.
Wait, no, not that yet. If you go and highlight something, take that tool, and then run that over the thing you want. Boom.
Oh yeah,
I'm loving that tool.
that's cool.
Yeah. There we
You
go.
know, a new tool that I just recently discovered on Google Slides. I don't know, maybe you guys probably already knew about this, and you'll be like, "Oh, that's lame. I knew about that a long time ago." Did you know that there's a crop tool that will crop in different shapes? Like you can actually in the shape of like circles and hearts and different things like that.
Where is that at?
So like where you normally go and like and crop at.
Like in like drawing?
Like, yeah, like no, in your Google Slides, like go like where you have the crop option. I think you got to hit on the little 3 little dots wherever those are, because I don't see crop up there. Or hit the
Usually I'll go Goober at my page.
yeah.
I thought
Yeah, there it is. See the crop button
Oh, this
now up
one,
at the
yeah.
top?
Uh-huh.
Yeah, go to the right there. See where now click on shapes.
Oh.
And so now what you can do is you can pull down there. So like you can pick a shape that you want. Like let's say you only want to cut out the circle of your face. Click on circle, watch. And now go cut out. Now you can make it just cut out only the circle of your thing right there. You gotta play around with it a little bit. But it's pretty cool because like if there's like sometimes you find like an image on Google that you want to use for something and you want the circle and you don't want the background that comes with it, you can cut out just the circle.
That is so cool.
Yeah, I just discovered that last week. I was proud of myself.
Yeah, because now oh wow, look at that. And then it got rid of all that extra. So then
It's kind of cool for like making collages and stuff, because you can cut out like, you could do like a heart crop of, I don't know, your favorite heartthrob or whatever. I don't know. Kids would probably have fun with that if they knew how to do it.
that's cool. So I made a heart out of my smiley face.
Exactly.
So cool. I didn't even think about that.
I don't even know if that was there before, if they just added it, but I just found out about it like last week. I was curious.
That was really neat. Well, thank you for putting your equation there. I was going to say, I'd be curious to see what made the pumpkin. I like the troll. Troll is cool. That's really cool. So you got to kind of like draw all that. That's really neat. Oh, that's cool. That's like a Pokemon ball. You should put in your equations how you got the Pokemon ball.